Hello everyone, Chigui here. Today, we're jumping right into a quick revision on one of my absolute favorite topics in physics, light and optics. Trust me, by the end of this, you're going to feel so much more confident for your exams. So let's get started.
So, let's start with a question. You've definitely seen this, right? After it rains a little, the sun peeks out, and bam, this beautiful arc of colors just appears in the sky. It seriously looks like magic. But what if I told you it's pure, awesome science?
And what about this one? We see it every single day. You look up, the skies are bright, beautiful blue. But then in the evening, as the sun sets, it just transforms into this incredible painting of reds and oranges. How can the same sky do that? Well, the great news is these are not magic tricks at all. It's all just physics. And today, we are going to unlock every single one of these secrets. Think of me as giving you a scientific toolkit to understand not just these cool things, but so much more about how our world works. Okay, so to understand everything, we first need to learn about the superpowers of light. There are a few core concepts that, once you get them, will explain everything from your reflection in the mirror to how a rainbow is even possible. Our first superpower is reflection. It's really simple. It's just when light rays hit a surface and bounce off, kind of like a tennis ball hitting a wall. This is exactly what's happening when you see yourself in the mirror every morning. And the rule for this is the law of reflection, and it is beautifully simple. The angle the light comes in at, which we call I for incidence, is always equal to the angle it bounces out at, R for reflection. Simply put, I equals R. They're always the same, no exceptions. Okay, now listen up everyone. This slide is super important. This is a guaranteed exam question. You absolutely must know how to draw and label this diagram perfectly. The incoming light is the incident ray. The one that bounces off is the reflected ray. And that dotted line right in the middle, perpendicular to the surface, that's the normal. Please memorize this. Superpower number 2 is refraction. Now, this is what happens when light bends as it passes from one thing into another, like from air into water. You've seen this. It's why a straw in a glass of water looks like it's broken, or why the bottom of a swimming pool looks way shallower than it really is. The light literally changes speed and bends. Next up, we've got dispersion. This is the rainbow maker superpower. When normal white light from the sun passes through something like a prism or, you guessed it, a water droplet, it actually splits up into its 7 component colors. You know them: red, orange, yellow, green, blue, indigo, and violet. And our final superpower for today is scattering. Now this is when light rays hit tiny particles in the air and get bounced off in all directions. It's not a clean, neat bounce like in a mirror. It's a messy, all-over-the-place kind of reflection. And this messy process, this is the secret to why the sky has any color at all. All right, so now we have our toolkit of superpowers. We've got reflection, refraction, dispersion, and scattering. Let's go back and solve those 2 big mysteries from the beginning. You ready? So how is a rainbow actually formed? Well, it's a team effort using our superpowers. First, sunlight goes into a single water droplet. As it enters, it immediately gets bent and split apart. That's refraction and dispersion working together. Then, those 7 colors hit the back of the droplet and bounce off. That's reflection. And finally, the light comes out of the droplet, bending one last time, refraction again, on its way to your eye. See? A perfect combo of 3 superpowers. Now for the sky. This is all about scattering. At midday, right, the sun is high up, and its light travels through less of our atmosphere. The tiny particles in the air are really good at scattering short wavelength blue light. So that blue light gets scattered all over the place, and the whole sky looks blue to us. But at sunset, the sun is low on the horizon. Its light has to travel through way more atmosphere to get to you. By the time it does, most of that blue light has already been scattered away, leaving only the long wavelength reds and oranges to come straight to your eyes. So cool, right? Okay, so this stuff isn't just about pretty rainbows and sunsets. We use these principles everywhere. Let's take a quick look at how these superpowers are used to build the amazing technology we see every day. Take mirrors, for example. The simple, flat, plain mirror in your bathroom, it gives you a normal, same-size image. But a concave mirror, the one that curves inwards, it magnifies things. That's why your dentist uses one to see your teeth up close. And a convex mirror, which curves outwards, gives you a smaller image, but a much wider view. That's perfect for security mirrors in shops or the side mirrors on a car. And it doesn't stop there. Submarines use periscopes with 2 simple plane mirrors to see above the water. And hey, Have you ever noticed the word ambulance is written backwards on the front of the vehicle? That's so drivers can read it correctly in their rearview mirror because of something called lateral inversion. Even interior designers use big plane mirrors to cleverly trick our eyes and make small rooms feel way more spacious. It's all just clever physics.
Okay, class, listen up. High energy, rapid fire time. This is the crucial, must-know information for your exams. Let's make sure you nail these questions.
First up, the speed of light. It's a constant. 3 times 10 to the power of 8 meters per second. Just memorize this number. It's fundamental. You just got to know it.
Next, color addition. They love to ask about mixing the primary colors of light. Remember, this is different from paint. So, red plus green gives you yellow. Red plus blue gives you magenta. Blue plus green gives you cyan. And what if you mix all 3, red, green, and blue? You get white light back again. Make sure you know these combinations. And let's drill this into our heads one more time. The law of reflection. What's the golden rule? The angle of incidence is always the same as the angle of reflection. I equals R. Don't you forget it. So there you have it. From rainbows in the sky to the mirror in your room, light and optics are all around us, and they're governed by a few simple but super powerful rules. We figured out so much already, but what do you think is the next big optical challenge for science to solve? Have a think about that. Thank you so much for watching. Study smart, and I'll see you in the next one.